It's your friendly math tutor, Miss C here, and today we are solving quadratic equations that are written in vertex form. So you can see we have our equation written in vertex form here. We're going to follow a series of steps. The big idea to keep in mind is that as we are moving from these steps, we are solving for our variable x. All right. There's a couple ways to do this. I'm showing you the most efficient way, and that's what these steps are about. So anytime we're solving a quadratic equation, and there is a y involved, we always substitute 0 for y. So we're essentially finding the roots or the x-intercepts, or sometimes they're called zeros of our equation. All right, our first step is done. Our next step says that we are to follow the order of operations. And in the United States, a lot of times we call that PEMDAS. Sometimes this is called BIDMOS in other countries. Basically, what we're doing, and we're doing this backwards. And the reason we're doing it backwards is because we are moving things across the equal sign. We group addition and subtraction together and multiplication and division together. And this guides our steps as we work to get x by itself. So I'm just going to keep highlighting this because our goal, everything we're doing is to isolate x. So we're going to start with addition and subtraction right here. I am noticing that I have 3 being added. I also see that I've got a positive 7, but I'm noticing that this whole binomial is being squared, which means I can't move anything out inside that parenthesis outside. So I can't do anything with that right now. So I'm going to deal with this one, and I'm going to subtract 3 from both sides. Some people find it helpful to draw a vertical line down the equal sign so that they are actually doing things to both sides instead of just one side. All right, so I have negative 3 here equals half times the quantity x plus 7 squared. And then 3 minus 3 is 0, and that's exactly what we wanted to get. All right, now we're looking for any multiplication and division. So I'm noticing that I have the half is being multiplied by my binomial. So you can either divide both sides by half, right? Because we're doing the inverse of the multiplication, or you can multiply both sides by 2. And that is always my preferred way of dealing with fractions, is to multiply by their reciprocal. It's the same thing as dividing by half. I just feel like I make less errors that way, and I've seen that work for students. All right, so we're left with this. Also, just by the way, half times the quantity x plus 7 squared, it's the same thing as this. So if you see this expression right here, it's the same as half times quantity x plus 7 squared, just as a side note. All right, now we are moving to exponents, and I do in fact have an exponent. I have a square here. So the way that we get rid of squares, or we unsquare, is by taking the square root. So I'm the one physically drawing the square root bar on this side and on this side. And because I'm the one that is doing that operation, I have to throw a plus or minus here in front of what I've square rooted. That means it could have been a positive times a positive or a negative times a negative to make this squared value. All right. And on this side, the square root undoes the square, so I'm left with x plus 7. All right, we have no parentheses left. What that means is we start the order of operations over again, and we're back to addition and subtraction. I am in pursuit of getting this x by itself, so I'm going to subtract 7 from both sides. All right, that leaves us with, I cannot combine that negative 7 with what's under the root bar because it's trapped. So negative 7 gets kicked out front, plus or minus the square root of negative 6 equals x. Okay, that is your root. Now, some people might think this is an okay answer. By the way, my third step was to simplify the radical. Technically, there's no perfect square in here. If I were your teacher, I would say I would actually like you to get that negative outside. So while this is not technically incorrect, it could be better. So now I'm going to go ahead and I'm going to simplify. No perfect square in here, but what I can pull out is the square root of negative 1. And I'm going to multiply that by the square root of 6 equals x. So I end up with negative 7 plus or minus. The square root of -1 is equivalent to I, to the imaginary number I, times the square root of 6. And this is how we write this, equals x. This is the best answer. This is how I would want my students to write their answers. Okay, so -7 plus or minus I times the square root of 6. Just a pro tip here, we always write I out front because if we write it on the back, sometimes it looks like it's under the root bar, and we don't want that. So that's why we kick it out front. All right, and there you have it. Here is how you solve an equation in vertex form and end up with an imaginary solution. If you found this video helpful at all, please like it so other people see it, and make sure to subscribe so you don't miss a video. Till next time, remember, you've got this.